Hello guys, and what's up, and welcome back to my channel. So how are you guys doing? Hopefully you guys are doing fine and stay safe in this severe pandemic. So in this video, in today's video, I'm going to talk about vector topic. So this is kind of interesting topic because I love this topic very much also. This topic is in additional mathematics. So let's without further ado, let's have a look on it. So vectors. So what are vectors quantities? So it is the quantity that have two specific properties, or you can say characteristics. So what are the characteristics? So there are directions and magnitude. So if you realize here, I underline the direction over there, as you can see, because this is the difference between vectors quantity and also the scalar quantity. So it is indicated by head arrow. You will see in the next part. So magnitude, which tells you about the value, and it always positive. So what are the examples of vectors quantity? So we have so many over here. So we have displacement, velocity, acceleration, forces. So forces here, we have so many forces like electromagnetic force, frictional force. You have what else? Electrical forces. What else? Gravitational force, and so on. Push and pull force, and you will also have torque as the vectors quantity. And also we have angular momentum, moment force, and so on. And what are the applications? So is that really important to me? Of course, yes. So actually in engineering, the vectors are applied. So my intention of introducing you the applications over here is to give you kind of intuition of vectors, what really vectors are. So it is quite frequent being used in engineering, like aircraft engineering, you can say, probably any kind of air traffic controller job, and of course in physics field, mathematics, programming, game developer. Maybe you guys do not believe with this programming, game developer, and also animators job using vectors, but the reality, it is, because it is dealing with what we call motion, and motion must have its own direction and magnitude, and etc. Okay, let me explain a bit so that you guys have the intuition. Okay, let me explain about the physics. In physics, for example, we have the axis, the x and y axis. So for example, if we have the force initially from the origin 0, 0. So for example, the force A is in this direction. So this is the direction represented by head arrow. This is head arrow. 10 Newton. So 10 Newton is the what we call magnitude. And next, 15 Newton to the bottom. So this is the direction, and this is the magnitude. And we also have the third force vector over here, probably 5 Newton, the smallest among all. So my question is, find the resultant force vector. How? So this is where vectors come to the rescue. So in order to find the resultant false vector, you need to resolve one by one and then add them up, okay, using various methods. So we will cover the vector addition in future video, but not in this video, because in this video I'm focusing on the introduction of vectors. And also we can take example of the animator or game developer. When you are interested to develop a new game, you need to have a better understanding and deep understanding in vectors, of course, because you are dealing with motion. So when you are creating a character in games, you need to make it move according to the person who control it, or which is me, the player, for example, which is me, the player, using the analog. Okay, so the developers need to have a better understanding so that the character can move, can run, can anything, perform a motion perfectly and without any defect. Okay, so next, so let's let me introduce you with a vector notation. So suppose we have here a vector, what we call it, Cartesian plane. So this is x-axis, y-axis, and this is point, for example. What you want to call it? Point A, of course. Everybody love the alphabet A. So this is point B, and it forms a vector called vector AB. Okay, agree? Vector AB is from here, from here to here. If vector BA, different. Vector BA is arrow towards the A alphabet over there. Okay, so let me give the coordinate system for A. Probably 1 3. So 1 3. How about B? B is 7 2. This is 7. This is 2. Okay, like that. And one thing you need to know, that this A is not an ordinary point. We can call this point A as position vector. I think in your syllabus you are not learning it, but maybe this is an extra for you. So a position vector has a reference point from this origin. Okay, but let's just presume that we do not have any idea about position vector, but in advanced level you will discover those things. So where's my marker? Okay, over here. So how to find vector AB? So you know the coordinate here, A13 and B72. Okay, so you can find vector AB by simply from 7 minus 1, which represent the x component, 6 and 2 minus 3, which is minus 1, of course. So I'm using this kind of weird bracket instead of this bracket. This bracket can only be used when the vector is a position vector, because the position vector has the origin of over here, 0 0 point origin. But you can also use this kind of weird bracket for position vector. Okay, so for the vector like this, you cannot use this like this parenthesis. You need to use this weird bracket. I don't know what does the name, but let's just say weird bracket. 6 negative 1. So simply from the end point, which is B, minus the coordinate system of the initial point. So 7 minus 1 is 6. 2 minus 3, which is negative 1, simply like that. Or you can, okay, so this place represent the x component, and the second place representing the y component. Later you will see the logic behind this. Okay, so let's let's prove how we can get this shortcut method. So suppose, okay, how you want to travel from A to B. You can use the alternative, travel from here over here, okay, to the bottom or to the south, you can say, and from here to here. Okay, so this is exactly like this. Okay, so I said this, okay, this one represent x component, y component, and this one represent the x component. So COMP is component. Okay, so we can represent this also with, so from A to over here, how many unit? 1 unit. 1 unit. But since it is heading to the bottom, so we need to use negative sign. So the negative here indicates the direction. So as I already mentioned, the magnitude must be positive, but this negative literally means the direction of, okay, the direction, not the magnitude. You must remember that. Okay, and from over here, which is supposed to be 1 at x coordinate, and towards this path to the point where x equals to 7. So how many units it travels? So it is simply 7 minus 1, which is 6 units. Since it is to the right side, so it is positive. So remember, if you have if the vector travels from to the top like that, it is positive, or to the right, it is positive. Okay, but otherwise, when it travels to the bottom or downwards or to the left like that, it is negative. You must keep that in your mind, of course, because that's important when you resolve a vector in physics. Okay, so how to represent this? So we know you can use the general vector notation, which is AI plus BJ. Okay, so this I is nothing but just representing the x component, and this J representing the y component. Okay, so then we can represent vector AB as, so A is how much the x component, how long or how big the x component is, positive 6. I, and B representing the how long or how huge, how big, what is the value of the y component over here, is negative 1j. And this is the second way to represent beside of this way. Or you can also use the matrix form like this. It is actually similar to this, but the only difference is like this. Okay, you are representing it, I think this is row by row. So this is first row and this is second row. Row. Okay, so this is for the first place representing the x component, and this is representing y component. Okay, this is three different ways to represent vectors. Okay. I think why not we are talking about the magnitude together. So if you realize over here, I do not assigning any magnitude. So let the magnitude is C. So magnitude, how we represent the magnitude by notation is like this, by using the absolute value or modulus symbol like that. So this is representing the magnitude. Okay, something lah. Unit. What is the method to find the magnitude or to find the C over here? So if you realize and look carefully, this is the right triangle. If so, we can use what? Theorem Pythagoras, of course. So we assume this length is all in positive because we are dealing in magnitude. So this is 1 unit in magnitude and this is 6 unit in magnitude. So we are not concerned about the positive sign, negative sign, because it is about magnitude. So how to find the C? So C basically is the hypotenuse, and we can use the following formula, which is a square plus b square equivalent to c square. C is equivalent to square root of a square b square. So C over there is 1 square plus 6 square, 37 unit. You can press your calculator and find the exact value in decimal form of 37. Okay, so actually it is the right way to know to calculate the magnitude. Okay, so actually you have a shortcut over here to find the magnitude. So suppose we know that AB is simply 6i minus j, so actually it's 1j, but why not just use not writing the 1 over there, because it is the same thing. So we know we can use this kind of shortcut formula. So this 6 square from over here always plus with the second y component, which is 1 square, set of them, and we get the magnitude, which is the same. Okay, 37 units. So that's the shortcut, actually being derived from theorem Pythagoras or right angle triangle. Okay, let's have a deep look on vectors. So I hope you are not acting like this. Vectors are easy. So if you have kind of a vector in space like that, A, B, and is this a vector? No, because I'm not assigning any magnitude. So it has a magnitude, for example 2 units, and this is a vector. And if I ask you, is this a vector? No. If I want to make it a vector, it must have a direction like that, or direction like that. Okay, so this is not a vector. So of course it must have, for example, this is 10 units, this is 7 units, whatever. Okay, so that's the basic of vector in space. So let's talk about parallel vector. So maybe you are familiar with the word parallel. Parallel is something that is parallel. Okay, so parallel, so this is vector A, this is vector B. So the vector are said parallel when they have the same direction and regardless of the magnitude. Okay, so though you already know the definition for parallel vectors, So over here we have vector AB is said to be parallel to the vector CD, even though the magnitudes are different, which is 4 units. So U over here is units, okay, not a variable, it is a units. So 4 units and 2 units. So since there are having the same direction over there, so we said there are parallel regardless of the value of the magnitude. What about this? This is vector EFGH, so it has a magnitude of 5 unit. So of course they are parallel because of the direction the same, and we can also say them as the equal vector. Okay, and how about vector okay, like that. Okay, let me assign a magnitude. So this is 5 unit, this is 1 unit, and the direction is over there and towards there. Are they parallel? No, because they have no they are having different directions, so they are not parallel. Instead we call them as anti-parallel. So actually parallel, we can represent this by using a scalar multiple. So if AB is parallel to CD, then AB is equivalent to n times CD. So vector must have this head arrow, remember? So obviously we know n is equivalent to 2 because vector AB is 2 times bigger than vector CD, because 2 times this 2 is 4 units, and it is obvious. And since the second case is simply vector EF is equivalent to vector GH, because they are similar, so we just equate them using the equal sign. And this is we can still equate them. So let me give a name, vector XY in WZ. Okay, so vector XY is equivalent to m times the m is the scalar multiple or the constant WZ. Okay, so we know m is equivalent to 5. Okay, sorry, yeah, 5, because no, negative 5, because since they are having a different direction, so we are using negative sign. Since XY is 5 times longer than WZ, then we are knowing that m is equals to 5. Okay, so negative here indicates the direction. Remember that when they are having a different direction, we are assigning a negative sign. So what about collinear? So collinear is kind of similar to parallel, but the difference is when 3 points is said to be collinear when they are in the same straight line or in the same vector line. So this is point A, point B, point C. Okay. So this is point A, point B, point C. Let me connect the point. So vector AB over there, I represent by the small case vector A, and this is BC is represented by small case B, vector B. Okay, so we can say that vector A is collinear with the vector B. Okay, and that since we have 3 points lays in the same vector line, like this situation, as you can see. Okay, what about normal? So normal have a what we call unique name, or the other name, which is the orthogonal. I think that's the way to spell it, I hope. Orthogonal is when two vectors, okay, vector A, so this is vector A, yeah? So we have here vector A, and for example vector B is heading towards there. So this must be 90 degree. They must form a 90 degree angle to be set as an orthogonal. So we can say vector A, we can represent a vector like this also. Later I will explain. Is orthogonal to vector B. Okay. So the scalar multiple or the scalar product is equivalent to 0. So you don't have to concern about this, because this is just a extra. All you need to know is about the orthogonal vector, or the normal vector must form a 90 degree angle with each other. And magnitude, okay, actually magnitude I had been discussed or tell you in the previously. So it is simply using theorem Pythagoras. Okay. Unit vector we will discuss in the future video, so just wait and stay tuned. So for a better intuition and to let you guys to better imagine of vector, let me give you a single example. Okay, so since we know that displacement is a kind of vector quantity, so one type of vector quantity, so this is a good example, I think. So suppose this is me, okay, this is my house, my home, okay, I denoted by capital S, stands for starting point. Okay, I was traveling from my home and I want to buy something at shop, so I'm traveling heading to south, and this is a vector, remember, it indicates an arrow. So it is for example 4 kilometer. Wow, very far. And then I decided to go to my friend's house, okay, which is have a length 5 kilometer, and decided to go to the bank probably, and at 1 kilometer distance, and decided to went back to my home. Of course I am using this path. I'm not that stupid to use this path, and which is more far. So it has the length of 6 km. My question, what is the displacement? Maybe you would answer it as 6 plus 4 plus 5 plus 1, which is 16 km. But it is totally wrong, because this is a displacement. We are dealing with what? Vectors. Vector has what? Direction. So we need to take into consideration the direction also, not even the single magnitude. So what exactly its displacement, or my displacement? So taking into account the direction, suppose I was starting from home and I was ending my journey or reaching home at the end. So basically my displacement is 0. It is kind of logical, because your direction is not changing basically, right? But the magnitude it is, but your direction is not changing. So basically you are traveling 0 kilometer. Another approach to understand this kind of thing is like, let me divide this into several portions. So this is 1 kilometer over here, and this is 3 km of course. Okay, remember when I said that downwards or heading to the bottom is negative, and towards the left is also negative, and heading to the top, or what we call upwards is positive, and also heading to right is positive. So using this concept, okay, so my displacement is equivalent to, so first from home to shop is 4 kilometer. Remember to include the direction to the bottom, which is -4, plus, since we want the total or the summation of the displacement, so we add from shop to my friend's house, which is +5 kilometer, and always plus. Okay, to from my friend's house to the nearest bank, which is 1 kilometer, so +1, because heading to the top, always plus. So how about this? What sign we should use? So suppose we can resolve this into two components, which is x and y. So when you are from here to here, actually the alternative here, you can travel from here to here is the same thing, right? So from here to here is, you can reach this same like from here to here, right? So I'm using this path, so this is 5 kilometer to the left, so -5, okay, and from here to here -5, so from here to here is +5, because towards upward or towards top, so +3. Okay, so this is +3, okay, because towards the up, towards the what we call top or upwards. So this is negative, so this is positive. So okay, let us add this up. So -4 plus 5 plus 1, so this is -5 plus 3 is -2, so is equals to what? Of course 0, right? Equals to 0. So actually it is another way to look on why my displacement is 0 kilometer. So when we are looking into this distance perspective or the scalar perspective, so this is basically a scalar quantity because it is distance. So from starting point to shop is 4 kilometer, so I don't have to indicate the direction. So 5 km to here 1 km. So suppose this path are the same, but my drawing are the bed. So this is 6 kilometers. So distance simply when you add them up. Okay, so 6, 4, 1, 5 being added up to become 16 kilometer. So that's basically the how you could see vector in a different perspective or in a different insight of view. So I think that's all for my vector introduction video. In a future video, in the next video, I'm going to talk about addition of vector and solving a problem, specific problem in regarding vectors, which is kind of interesting, I think. So see ya in the next video, and thank you as always.